Hi everyone, welcome back to chapter 2.3 HESS'S law. Here is our part 2 video. In this video, we are going to talk about dissolution process of ionic solid. So dissolution process means that we are making a solution from a solid ionic compound. So in this process, when an ionic compound dissolves in water, there will be some enthalpy change. That means heat will be released or absorbed. So this solution process can be divided into two stages. The first step involving breaking down the crystal lattice into gaseous ion, and the breakdown process requires energy. Therefore, it is positive. It has a positive enthalpy change, and we call it as the enthalpy of lattice or lattice energy. The second stage involves hydration process. Okay, hydrations of separated gaseous ion by water molecule. So we recall that enthalpy of hydrations release energy. Therefore, enthalpy is negative in value. So in this process, we're using a general diagram. So as you can see over here, we have solid ionic compound MX. So this will be in solid. So normally we will just dissolve in water to get a solution, isn't it? So dissolving is the enthalpy of solution or dissolution. So you are creating an aqueous ion. So M plus X minus. So this one is in general. Okay, so but in actual, this process involves two stages. So first one, we want to break down this solid ionic compound into its respective gaseous ion. Okay, so breaking down process requires energy. So this one will be in positive value. Okay, and then we have this gaseous ion form. So after that, we need to hydrate all this gaseous ion. So M plus gaseous ion, it will become M plus aqueous. So gaseous ion into aqueous ion. Similar for X minus into X minus aqueous. You're only changing the phases. Alright, so madam, using a simple diagram, hopefully you can understand about this one. So if you want to dissolve a solid ionic compound, okay, and then we want to make an aqueous solution, so this refers to your enthalpy of dissolution or enthalpy of solution. That means the same thing. So this one involving the breaking down of the solid compound into the gaseous ion. So it's changing the phase from solid into gas phase. So for this solid into gas phase is a lattice energy. Okay, so lattice energy, we will discuss this one in chapter 2.4. And breaking down required energy. Therefore, it will have a positive value. And after that, we want to hydrate this gaseous ion into aqueous ion. So this will be your enthalpy of hydration. Okay, so according to the HESS'S law, as you can see here, okay, so if according to HESS'S law for this cycle, you can see enthalpy of dissolutions, I make it A, lattice energy, I make it B, and these directions continue with the enthalpy of hydration, I make it C. So that means A equal to B plus C. So in short, I can make my equations enthalpy of dissolution is equal to lattice energy plus the enthalpy of hydration. Alright, so this one, the additions notes for you. If the lattice energy is positive, it means that energy is required. So solid will break down into gaseous ion. So bond dissociations require energy, or bond breaking required energy. If this energy, lattice energy is a negative, that means we convert from gaseous into solid. So gaseous will form solid. Okay, the molecule between solid is closely packed. That means it is a formation, bond formation. So formations of bond will release energy and it is negative in value. So this lattice energy we will talk into detail in chapter 2.4. So for this example, questions number 4, explain briefly the dissolution process of KF qualitatively. So that means you need to explain it in sentences. So recall that the dissolution process involves two stages, which is breaking down the solid into gaseous ion, and then you do the hydration. So the answer goes this way. The ionic solid Kf, potassium fluoride, is separated into gaseous ion K plus gases and F minus gases. So this is enthalpy of lattice energy. This process required energy, which is endothermic reactions, to overcome the electrostatic forces between the ions. So bond breaking required energy. Next, these gaseous ions will then be hydrated into water. The electrostatic forces of attractions between gaseous ion and the polar water molecule causes the ion to be surrounded by water molecule. Or in short, you can mention this one as the enthalpy of hydration. So enthalpy of hydration refer to when 1 mole of the gaseous ion is hydrated. So hydration's releasing energy. It is an exothermic reaction. Alright, so questions number 5. Lattice energy for potassium fluoride Kf is negative 281 kJ per mole, and its enthalpy of hydration is negative 819 kJ per mole. Calculate enthalpy of solutions for potassium fluoride Kf. So for these questions, you will need to draw the energy cycle referring to the dissolution process. Okay, so we start off with the solid ionic compound Kf, solid. Alright, so when you want to dissolve to form a solution, so we break down into Kf aqueous plus F minus aqueous. So this is our enthalpy of solution. Okay, so for this dissolution process involving two stages, first you need to break down into its respective ion, which is K plus in gas and F minus in gas. So this is the enthalpy of lattice or lattice energy. And then going upwards is your enthalpy of hydration. It doesn't matter how you go, as long as it proceeds from solid to aqueous, and then you mentioned about the progress, solid break into gases, and then do hydration. You want to do it like before this, when you did it this way, aqueous, solid to aqueous, solid to gas, and then gas to aqueous. That's fine. That's fine, as long as your direction is correct. So now, enthalpy of solution is what we want to find. Okay, and then the lattice energy given here is in negative. So remember that we say that from solid into gaseous, okay, for solid into gases, it requires energy as it is a bond breaking process. Okay, but then this one giving in negative. So we need to do it in positive 821 kilojoule per mole. So solid into gaseous require energy. Therefore, you change the sign straight away. Okay, kilojoule per mole. Okay, and then next enthalpy is enthalpy of hydration given here is negative 819. So we enter this one. Hydration proceeds from the gas into aqueous. So negative 819 kilojoule per mole. So you check again for the definitions of enthalpy. So enthalpy of solution when 1 mole of the solid ionic compound is dissolved. So this one's 1 mole, that's good. So hydrations, when 1 mole of the gaseous ion is hydrated, so this one is 1 mole, this one is also 1 mole, so the value are the same. You don't need to multiply or divide anything. Okay, so go back to the definitions again. So please take notes on the phases that you're going to use as solid, aqueous, and gas. So according to the diagrams over here, or according to the diagram that you have drawn, if you look from the directions, we have a single directions from Kf into the aqueous ion. Okay, and then we have the lattice energy, which the solid break down into the gases. And then after that, we have this hydration process. So starting point, ending point. So let's just label this one. Enthalpy of solutions I label as A, which is a single steps. Enthalpy of lattice I label as B, which is a series of steps together with this enthalpy of hydration. Therefore, if you can see over here, one steps equals to the total of enthalpy change of a series of steps. So in this case, A equals to B plus C. So we make our equations. Enthalpy of solutions equals to lattice energy or enthalpy of lattice plus the enthalpy of hydration. So substitute back the values of positive 821 minus 819 to give you a positive 2 kilojoule per mole. So this positive refers that energy is absorbed for this enthalpy of solutions. So if you refer back to the definitions, it means that heat change. Okay, it can be positive, it can be negative. All right, so please go through the notes over again and understand the process where the dissolution process involves 2 stages. So that's the end of our chapter 2.3. Please attempt the exercise for our chapter 3.3. So that's all for the video for now, and thank you.